Ultraviolet radiation, and what makes it unique is that we have actual results. We have prevented a very serious damage.
So, what are chlorofluorocarbons? They're non-toxic, non-flammable organic chemicals containing atoms of carbon, chlorine, and fluorine. They're used in the manufacture of aerosol sprays, blowing agents for foams and packing materials, and as refrigerants. They were much used in the middle 20th century, replacing chemicals that were toxic or flammable or had traits that were generally harmful to human health. Let's talk about the ozone layer. Most atmospheric ozone is concentrated in the layer in the stratosphere, about 9 to 18 miles, which is 15 to 30 kilometers, above the Earth's surface. Ozone is a molecule that contains 3 oxygen atoms. At any given time, ozone molecules are constantly formed and destroyed in the stratosphere. The total amount has remained relatively stable during the decades that it has been measured. The ozone layer in the stratosphere absorbs a portion of radiation from the sun, preventing it from reaching the planet's surface. Most importantly, it absorbs the portion of UV light called UVB. UVB has been linked to many harmful effects, including skin cancers, cataracts, and harm to some crops and marine life. Beginning in the 1970s, however, scientific evidence showed that the ozone shield was being depleted well beyond natural processes. When chlorine and bromine atoms come into contact with ozone in the stratosphere, they destroy the ozone molecules. One chlorine atom can destroy over 100,000 ozone molecules before it is removed from the stratosphere. Ozone can be destroyed more quickly than it's naturally created. This is what chlorofluorocarbons resulted in. The excessive use of chlorofluorocarbons resulted in a rapid depletion of ozone to such an extent that it created the Antarctic ozone hole.
How did we realize that the ozone layer was depleting? In 1985, Jonathan Shanklin was a junior researcher at the Bachelor of Applied Science when he discovered a hole in the invisible shield that protects us from solar radiation. He was supervising and checking the ozone data coming back from the BAS ozone spectrophometers in Antarctica. They took readings of the spectrophometers, which shows how much ozone is present in the atmosphere. He decided to compare the readings with the ones 20 years ago and discovered that there had been a depletion of the amount of ozone in the atmosphere. It's been 36 years since scientists first discovered the hole in the ozone layer. This is him talking about it.
Our discovery of the ozone hole some 30 years ago was an accident, but it led to tremendous changes in society. The effects of the ozone hole, if it had been left to itself, would have been enormous. But the world's governments, through the UN, have all signed up to the Montreal Protocol. That treaty is working, and today we're starting to see a recovery of the ozone layer. We do, however.
But exactly how did we fix the situation? By 1985, the globe had already seen advancements in the scientific understanding of the ozone depletion and its impact on human and health and the environment. It was then that the Vienna Convention for the Protection of the Ozone Layer was created in response. The Vienna Convention was the first convention of any kind to be signed by every country involved, taking effect in 1988 and reaching universal ratification in 2009. This speaks to the enormity of ozone depletion at the time and the willingness of countries around the world to work together to solve it. Today, the Vienna Convention is still making progress. The countries involved meet once every 3 years to make decisions on important issues, including on research and systematic observation, as well as financial and administrative matters.